Good morning, everybody. Today we're going to talk about properties of trigonometric functions. Okay, so a function is called periodic if there is a positive number p, such that whenever theta is in the domain of f, so is theta plus p, and f of theta plus p equals f of theta. Okay, so what does that mean? So, for example, and at this point you're just going to take my word for it, the sine function is periodic with a period of 2 pi. Okay, so sine is periodic with a period of 2 pi. That means every 2 pi you get the same answer. So, if I have a value for, say, f of, let's see, something easy. How about f of pi over 6? Okay, so the sine of pi over 6 is 1/2. That means that f of pi over 6 plus 2 pi is also going to be 1/2. And so is pi over 6 plus 4 pi. And so is pi over 6 plus 6 pi, and so on. Every 2 pi, you're going to get the same answer again. Okay? The cosine of 0 is 1. Well, the cosine of 0 plus 2 pi is also 1, and 0 plus 4 pi is 1. Okay, so that's what this means right here. Okay, now, why does that occur with sine and cosine? So let's just look at sine. This is a sine curve right here. This might be a little bit hard to see, so I'm going to go over it a little wider, brighter. It's a nice, good-looking sine curve right here. Okay? And this is 0, and this is 2 pi over here, and this is negative 2 pi over here. Okay, so if you look at what happens here, you get these right triangles, and you look at the side opposite, okay? So as this angle gets bigger, the side opposite gets larger. Okay, so if I look at this triangle right here, okay, the angle right here is smaller than this angle is, okay, and the opposite is shorter, and the hypotenuse is the same length, and the adjacent is longer. So what happens is the opposite over the adjacent, this is a smaller number over, let's say this is a unit circle, so this is always 1. So the hypotenuse is always 1. Well, if this is a smaller number divided by 1, then that's a smaller number. So as this angle gets bigger, this side gets larger until it goes straight up right here. Okay? Then the side opposite is actually the same as the hypotenuse, and the adjacent is 0. Okay? So that reaches, opposite is 1, and the hypotenuse is 1, so it's 1. And then what happens as it goes over here is that side opposite starts getting smaller again, and smaller, right? And smaller, until when it reaches straight over here, the side opposite is now 0, okay? And then as we go down here, the side opposite's getting bigger again, right? Except that the side opposite is now in the bottom half of the graph, so it's negative. Okay, and so on and so forth until it comes around over to here. So what happens is the sine starts out at 0, it gets bigger up to 1, and then it starts to shrink until it gets down to 0. That would be right here. And then in the bottom, the opposite side is negative, so it's a negative divided by 1, and this gets smaller and smaller until it reaches negative 1. That's going to reach negative 1 right here. Okay, and then it starts getting starts going this way again. So that opposite side starts shrinking. So you're getting, you're getting closer and closer to 0 again until it reaches right back here at 2 pi, and the opposite side is then 0. And then it just starts over. It goes right back up again, and it just keeps going around in a circle like this. Okay? So from making one rotation, starting right here, and going around this way, and ending right here, that is a period of 2 pi, because remember we said there was 2 pi radians in a complete turn. And so that traces out this part right here of that curve. And then it just starts over. That's what it means to be periodic. Okay. And then cosine, it does exactly the same thing as sine, except the cosine, it starts out at 1 because the side adjacent at 0 is the same as the hypotenuse. Okay? And so then the side adjacent, you can see as you're going this direction, the side adjacent shrinking down to 0. Okay? So you start out at 1, and then it shrinks down to 0 right here, and then it goes into negative, and then it comes back around. Okay. Now, so what is the domain? We need to talk about the domain and the range. So the domain of sine and cosine, I can put in any number I want. Okay, any number along the x-axis is in the domain. So the domain on both of these is the set of all real numbers. Okay, now what's the range? Well, the range is the numbers that come out. Okay, so it's all y's, where y is between -1 and +1. So -1 is less than or equal to y, is less than or equal to +1. There's my range. Okay, now let's look at, this is a sine curve right here. With this nice pretty sine curve. Now the cosecant is the reciprocal of that. So the reciprocal looks like this. Now it's got asymptotes here at pi and at 0, because at 0, sine is 0, and if I flip that over, 1 over 0 is undefined, it's infinity, right? So I have an asymptote here, same thing at pi. So I get these. The cosecant is just these u's that look like this, and it's periodic just like sine because it's all based on sine, right? It's the reciprocal of sine everywhere. So the period is still 2 pi. I get all the answers that I'm going to get between 0 and 2 pi. Oh, look, I get the same thing over here again, and I'm going to get the same thing over here again. Okay, but what's the difference in the domain and the range? Well, the domain here, the domain is all the x's, except I can't put in any whole pi's. Okay, if I put in 0, I get an asymptote. If I put in pi, I get an asymptote. If I put in 2 pi, I get an asymptote. Negative pi, I get an asymptote. Okay, so how do I write that? It's the set of all x's where x is not equal to pi k. All right, now what does that mean? Where k is a whole number. That's a little bit difficult to write. Okay, so what that says is, if k is a whole number, remember the whole numbers are -3, -2, -1, 0, 1, 2, 3, and so on, right? So I can't take any number and multiply it by pi and use that because that's not in the domain because I have an asymptote there. Now, what's the range? All right, the range is the numbers that come out. Okay, so what numbers come out? Well, I get all these numbers out except there's no numbers between -1 and +1. So, I would write, let's see, I gotta be careful how I write this. It's all the y's where y is less than or equal to -1, and y is greater than or equal to +1. Okay, so anything where y is 1 or bigger is okay, and anything where y is -1 or smaller is okay. Okay, so that's for cosecant. It's the same for secant because secant looks identical to cosecant, except that it's shifted over. So here's my cosine. It's shifted over because cosine's shifted over, right? So here's the secant in blue. Okay, so when I write the domain, the range is the same. Okay, the domain's a little different though. So when I write the domain here, the domain is all the x's. Okay, now x cannot be, these are multiples of pi over 2 here. So I've got pi over 2 and 3 pi over 2. So where x is not equal to pi over 2k, where k is a whole number. Okay, so there you go. All right, what about tangent? Okay, so tangent, you look at tangent here, and here, let me brighten it up a little bit in case it's hard to see. So tangent looks like this. Okay, again, I have asymptotes, and the asymptotes are every half pi. Okay, so it's all the x's. Where x is not equal to pi over 2k, where k is an integer. Whoops, you know what? Back here, I wrote whole numbers, and that's not true. These are integers. Whole numbers start at 0 and go up. And the integers have the negatives on there too. So this is an integer. Whoops, that should be green. Okay, sorry for that mistake. Okay, now what's the range? That's an easy one. The range is just all the y's. You can get any number out you want. I can get any number down to -infinity. I can get 0. I can get any number up to +infinity. The range is easy on tangent. Cotangent, same thing. Okay. The range, again, is easy. It's just all the y's. Okay. Now, the domain, it's very similar to tangent, except it's shifted over. So it's the whole pi's instead of the half pi. So the domain is all the x's where x is not equal to pi k, where k is an integer. Okay? Okay, so let's just talk about the periods here. So a period is when something takes on every value it's ever going to have. So if I look here, this is sine. Sine's going to take on every value it's ever going to have between 0 and 2 pi. So this right here is 0. This right here is 2 pi. So then it's going to repeat. So the period equals 2 pi. That's the distance from here to here. Okay, cosine, same thing. Takes on every value, takes on a complete cycle between 0 and 2 pi. So its period is also 2 pi. Okay, because sine and cosine have a period of 2 pi, cosecant and secant are the same thing. So you can look right here, cosecant has these values between 0 and 2 pi, so the period is 2 pi. And secant does the same thing. Okay, secant has this, and you don't have to go between 0 and 2 pi, you can do any range you want, so this is 0 and 2 pi. Like I could go from negative pi over 2 and I get this whole thing, and I don't need this half of one here, and I get the whole u here and the whole u here. And so that would be between negative pi over 2 and 3 pi over 2, but that's still a period of 2 pi. Okay, now tangent's different. So tangent, I get every value it's ever going to take right there, from negative pi over 2 to positive pi over 2. Well, that's a half a pi and a half a pi, so that distance right there is pi. So tangent has a period of pi. And because tangent has a period of pi, so does cotangent. Okay, so cotangent just goes from 0 to pi right there. So that's a period of pi right there as well. Okay, determining signs of trig functions. So you can look at this really easy. Now this is not to scale here. But if you look at triangles, okay, remember this is the opposite, this is the adjacent, this is the hypotenuse, okay? So the sine is going to be opposite over hypotenuse. Well, that's a positive number, and hypotenuse is always positive, it's always 1, right? So a positive over a positive is a positive. So sine's going to be positive up here. Cosine, the adjacent's positive and the hypotenuse is positive, so that's a positive over a positive, so that's a positive. And the tangent is the opposite over the adjacent, which is a positive over a positive, which is a positive. All right, well, so they're all positive up here. Okay. Now, let's look in the second quadrant. Remember, our quadrants go like this. It's quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? Okay, in quadrant 2, so this is my opposite, it's positive. My adjacent is negative now, and my hypotenuse is always positive. Okay, so this is positive, this is negative, and this is positive. Over here, these were all positive. Okay, so over here, my sine is going to be a positive over a positive, which is positive. My cosine is a negative over a positive. That's going to be negative. Okay? And then my tangent is going to be the opposite over the adjacent. That's going to be a positive over a negative, so that's also a negative. Okay, so just sine is positive over here. Okay, now I go down here, and I look at this quadrant down here. Okay, my adjacent is still negative, my opposite is now negative, and my hypotenuse is positive. Okay? So, let's look at the sine. Sine is opposite over hypotenuse. That's a negative over a positive, so that's negative. The cosine is the adjacent over the hypotenuse, so that's a negative over a positive again, that's also negative. And then the tangent is an opposite over adjacent, so it's a negative over a negative, that's a positive. So down here, tangent is positive. Now let's look at the fourth quartile here. Okay, so the adjacent is positive, the opposite here is negative, the fourth quadrant, sorry, and the hypotenuse is again positive. Okay, so we look at our sine. Our sine is negative over hypotenuse, so negative over positive, so that's negative. Our cosine is going to be adjacent, which is positive, over the hypotenuse, which is positive, so the cosine is positive. And the tangent is going to be the opposite, which is negative, over the adjacent, which is positive. So that's going to be negative. So down here, the cosine is positive. Now, there's a phrase that's going to help me remember this. Okay? So here's the phrase. All students take calculus. All students take calculus. And what does that tell you? That tells you which quadrants each function is positive in. Okay, all of them in the quadrant 1, sine in quadrant 2, tangent in quadrant 3, cosine in quadrant 4. So just remember the phrase, all students take calculus. And if you go look at your trig chart that we did the other day, you'll see that that's true. Okay. I'm going to skip these parts here because here's the thing. For cosecant, secant, and cotangent, they're all going to be positive. Okay. Over here, since sine is positive, cosecant is going to be positive. Down here, since tangent is positive, cotangent is going to be positive. And over here, since cosine is positive, then secant is going to be positive. Okay, now we need to get into the trig identity. So you're going to want to look at your trig chart or your trig formula sheet. Okay, if you don't have that in front of you, you need to print out a copy from Google Classroom or get one from me. Okay, so there are certain trig identities that I'm going to expect you to know, and these three are right up there. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. Okay? So if it's convenient for you, the reason you want to know these is sometimes it's way more convenient to write cosecant as 1 over sine than it is to write it as cosecant. Okay? Sometimes it's more convenient to write it as cosecant. You know, you'd rather have, instead, you don't want to deal with this, so you do that. And, you know, you could flip these around too and say, well, sine is 1 over cosecant, and cosine is 1 over secant, and tangent is 1 over cotangent. You need to have those memorized. Okay? Okay, this one is critical. This shows up all the time. The tangent is the sine over the cosine. Okay? Which brings us to the great mathematical mystery. Why do you never see a mathematician at the beach? And the answer to that is because they have a sine and a cosine to give them a tan. Okay? So, sine divided by cosine is just tangent. Sometimes it's convenient to write it like this. Sometimes it's more convenient to write it like this. And you'll see examples when you'd rather take this and turn it into this. Same thing with cotangent. It's just cosine over sine, because it's the reciprocal of tangent, right? I expect you to know these by heart too. Okay, the Pythagorean identities. These are also critical. You're going to use these all the time, okay? Sine squared x plus cosine squared x is always equal to 1. Now there's variations on this that come in handy. So if you use a little algebra and you subtract cosine squared from both sides, sine squared is going to be 1 minus cosine squared. Or if I subtracted the sine squared from both sides, cosine squared is 1 minus sine squared. These are all the same thing. They're called Pythagoreans because they work in the Pythagorean theorem. Okay? Critical to know this. This comes in way handy. There are so many times when you get a sine squared plus a cosine squared, and you can just say, hey, you know what? That's 1. I'm just going to replace that with a 1. Tangent squared plus 1 equals secant squared. Okay? Also true. All right, and there's variations on that over here. Okay, if I subtract the 1, then tangent squared is secant squared minus 1. Tangent squared minus secant squared is negative 1. Secant squared minus tangent squared is 1. Those are all the same thing. You know, this one I've always found, I mean, it's a Pythagorean, and you'd think you'd use it the same amount as you use these other ones. I've hardly ever used this one. But cotangent squared plus 1 is cosecant squared. And again, that works the same thing. Now, here's something I'm going to teach you that was a huge aha for me when I was taking calculus. I really struggled in calculus when I was a freshman in college. Really struggled with it. Couldn't figure it out, okay? And there were certain things that once I figured them out, it was like I had to take calculus twice, okay? The first time I took it, it was a disaster. I was getting tutored all over the place. I couldn't do it. The second time I took it, I actually had a really good teacher, and I'm telling you, a teacher makes a huge difference, okay? So make sure you have a good teacher. Find out who the good calculus teachers are and take it from them. But I kept having these ahas the second year I was taking calculus. And one of them, I don't know why I didn't see this before, but one of them is this. Sine squared theta, which is the same thing as sine squared x. What that really means is sine theta squared. Okay? Make sure you know that. I mean, it was like this big epiphany for me. It was like, wow, how did I not know this? And now a whole bunch of things make a whole lot of sense. Okay? I'm going to try to give you a few of those things as we go through the semester. But that was a big one for me. Okay? So that's what all these mean here. This is be cosecant theta squared. Okay, next you get your even-odd properties. Okay, we'll talk about these a bunch later, but sine of negative theta is equal to negative sine theta. So if what that means is if I have sine of a negative angle, I can just pull that negative sign out in front. Okay? They're called even-odd properties because if you remember, even functions are symmetric to the y-axis. So like x squared, that's an even function. Okay? It's symmetric. So that means that if I have an answer for a theta over here, I'm going to get the same answer for negative theta. Okay? Now, odd functions, if you remember, are symmetric to the origin. So like x cubed is symmetric to the origin. So if I took this thing and I rotated it 180 degrees, I get the same thing. Well, sine is an odd function. Okay, if you look at it, it looks like this. So if I take this thing and I just rotate it 180 degrees, I get exactly the same function. Okay, so with an odd, this property right here where you can take the negative sign out works for the odd functions. That's why this is an even odd property. Okay, so the sine of negative theta is the negative sine of theta. So what does that mean? That means, let's say I go out here let's say theta's Q. Say theta's right here. So negative theta would be kind of like right here. Okay, so there's theta, or there's f of theta, well, or sine of theta. Well, that's equal to the negative sine of negative theta, because see, they're the same number. This one's a positive number, this one's a negative number, so I can take the negative out, put it on the outside, and then it's just this. Okay? Now, cosine is an even function. It's symmetric to the y-axis because it looks like this. Okay, this one's even easier to see because if I go out here to theta and I go out here to negative theta, well, I get the same answer. Okay? So what that means is if I have a cosine of a negative angle, I can just get rid of the negative sign. Okay, again, tangent is an odd function, so I can pull the negative out in front. I can pull the negative out in front of cotangent. I can make the secant negative go away, and the cosecant, I can pull that out in front. Okay, so now it says, it gives me some things here. Find the sine of negative 45. Okay. Well, I can just pull the negative out in front of this, say, oh, it's going to be negative sine of 45. The sine of 45 is the square root of 2 over 2. So it's just going to be negative square root of 2 over 2. Boom, done. Exact value, do not convert this to a decimal. Okay, did it all in my head. Okay, cosine. Cosine of negative pi. Well, cosine, I can just get rid of the negative, so that's equal to the cosine of pi. All right, cosine of pi, I always have to draw the picture, I can never remember it. So, this would be pi right here, and cosine looks like that. So, hey, that's going to be negative 1. Okay, cotangent of negative 3 pi over 2. So cotangent, I can pull the negative out in front. Okay, this is not one that I have memorized. So let's see, cotangent of 3 pi over 2. If I look on my trig chart, that's why you want to keep these trig charts handy. Okay, so I go down here to 3 pi over 2, and the cotangent is 0. Okay? So that one I didn't really have to worry about much anyway, because negative 0 is just 0, so this is 0. Oh, now this one's different. The tangent of negative 37 pi over 4. Well, that's definitely not on my chart. So remember, tangent, I can pull the negative out. Okay, now that's still not on my chart. But remember, the period of tangent is pi. And since this is in fourths, that would be 4 pi over 4. So I can subtract multiples of 4 pi over 4. Well, let's see. 36 pi over 4, that's a multiple. I can subtract 36 from this. This is going to be negative tangent of pi over 4. So I just got to know what the tangent of pi over 4 is, and I think that's 1. Let's look on our chart. Tangent of pi over 4. That's 1. Okay, so this would be negative 1. You don't need a calculator for this stuff. Now, if you're doing something where you're going to use a calculator for this, make sure your calculator is in radians, or you're going to have a really bad time with your answers. Okay, finding the exact value of trig expression using identities. So remember, exact values, you very rarely use decimals, because unless it's like 0.5, which is exactly 1/2, it might be an irrational number. You need to write it with square roots and whatnot. So if we look here, tangent of 20 degrees minus the sine of 20 degrees over the cosine of 20 degrees. Okay, well, I'm not doing that in my head, but I can do this. Sine of x over cosine of x, that's just tangent of x. So this is tangent of 20 degrees right here, and then this is tangent of 20 degrees right here. I don't need a calculator to do this. I can do it in my head. It's 0. Okay, look at this scary bad boy right here. Sine squared of pi over 12 plus 1 over the secant squared of pi over 12. Well, let's see. Can I make this simpler? And generally you can, okay? So 1 over secant, that's cosine. So this is really sine squared of pi over 12 plus cosine squared of pi over 12. But wait, that's a Pythagorean. Sine squared plus cosine squared is 1. This is 1. It's like math magic. Okay, that's the end of our lesson. So, we got a worksheet here. Okay, some beautiful artwork here. Here's your problems that you're going to do, and that'll be due next time. And I look forward to seeing you next class.